say the small and large. Small and large element moment of inertia perspective. Perspective so think that actually the small and large cell elements it can be defined in this system that you know about the mode area that there is a center as nucleus and there is a different orbit that possesses diverse level of electron. Yeah? Here is the proton plus neutron. Here is the electron, different cell, different electrons. Yeah? And diverse level of electrons actually possess. It depends on the relationship of 2n square. That is the orbital. So whatever it is. So think that whenever we are talking about the moment of inertia, that is a body as a whole can rotate. It does not mean that the individual element will rotate. It is actually bonding each other and it rotates. So in a system, say this is an element that moving this that certain position is just moving surrounding this say here. If translational movement is this direction, the angular movement is this. So this is the del theta, this is del S. And if we think that the relationship between the rotational motion and the translational motion, then definitely we can say that the very small area, if we think, or very small periphery we think, it's very much straight. Yeah? So this is the del S and this is the del theta. So if so, then we can write that way that sine del theta is equal to del S by, say this is the R radius. R, yeah. So if the angle is too tiny, then sine del theta almost transferred to del theta. Actually it is del S by R. So if we make this derivative with the time, that R is changing the position with the time, then del theta by del t actually del S by del t into 1 by R. So this is actually, if we relate the del theta del t in the angular velocity, then that is actually omega. And that is actually, this is the linear displacement or translational displacement, it is the velocity with the time derivative, then R. So think that this is the first relationship between the angular velocity and translational or linear velocity. And that relation with the R. So think that if the angular velocity is not changing with the total rotation of 2 pi, yeah, the whole circle is 2 pi, while the translational displacement actually varying widely, because in our orbit there is a less translational distance compared to the outer orbit. So it means that this variation actually governs that if we consider the R is higher, then the translational velocity is getting higher. That S is the distance higher. If R is smaller, the inner orbit, then B getting smaller. So this is mysterious thing that the velocity actually varying with the radius. And that relationship actually is very interesting if we project this classical mechanics to the quantum level. That is a very important thing to interpret. But we are not studying here quantum mechanics, that's why I am not talking that. But the thing is actually velocity variation, translational velocity variation, the radius is very Very interesting because think that omega, the total rotational displacement is same. It's 2 pi whole, yeah, for a particular time. That means omega is not changing. While v is changing with r. That means whenever v is higher, then at the same time r getting higher to maintain omega or angular velocity constant. That is the important relationship, that how it governs this relationship. So now this issue actually, whenever we are talking about the atom, it is actually very less in terms of the dimension and mass as well. So we know that the moment of inertia, that framework we talk about, that thing that here a particle that applying a force F, that displacement having be less, actually this is the work done. So the F force we apply at a thing that this is R actually, that applying force actually R cross F. And that one we know from beginning, this is the moment, yeah? Moment here. That the force with the axis of the arms, that is the moment. We understood before at the beginning, that is the moment, that is sinusoidal function, the maximum value and the R cross F, that is the vector, that moment itself vector. So now the issue of the rotational motion, actually what happens? The rotational motion ultimately goes to the torque. How the relationship of the torque, and that is the important to elaborate. So the higher order, if you think that that force in a classical mechanics, that is the MA, so we can write it actually del P by del T. P is here, mv here, that is the linear velocity and mass. So think that this is the force relationship with the momentum and time derivatives. Then this is the linear case, that is follow the Newton classical mechanics second law. Then how about the torque? We know that the torque is associated with the torque tau equal to I alpha. We discussed this later several times. So that is actually the, here we make this the rotational force actually torque, and the linear or transitional force is F. Where rotational linear case we consider M, actually this M, and transitional case we consider M, rotational case we are considering I, and transitional case we are considering the acceleration is A, rotational case is acceleration is alpha. So that is actually come from here, that you make we again say the second derivative, that del omega by del t, that is get that del v by del t is 1 by r, that is alpha is equal to A by r. So this is actually, if we talk about that, you can come from here also, that F r, that is that relationship of moment that happened at the center is equal to the M, A and R. So think that if we write it very simple classical mechanics, that should be like this. So this is actually R, M and A is nothing but R omega, yeah. So this is actually M R square omega, yeah. So M R square omega, it is actually I omega, and this is actually the angular momentum. So this is the relationship between the angular momentum, moment of inertia and angular velocity. And this is the relationship of linear momentum, mass and linear velocity. So think that the association of these two drivers is different. That is here also involvement of mass, here involvement of inertia, moment of inertia. Here involvement of linear or transitional velocity, here involvement of angular velocity. So such way actually it is diverse, because whenever we are talking about mass, it is actually concentrating with a center of mass, and whenever we are talking about the moment of inertia, it is different dimension that relating with the relation with the mass and the axial radius square, that is actually here varying, because r is varying gradually different from different, and that's why everything is actually changing with the system. And the high velocity I attain the outermost stage, yeah, because you know the atomic model, if we talk about the atomic model, we know that the Planck's energy relationship equal to h nu, and h is c by lambda. So think that lambda variation and energy variation is interrelated, and that is you know that the periphery is 2 pi r of any circle, that it should be equal to n lambda, and that is the relationship between the lambda with the periphery and lambda with the energy. In that sense, whenever r is increased, definitely the energy is actually decreased, and that is the relationship of bonding, because between the inner electron and the nucleus, their bonding is very strong. You cannot open it, it cannot make free. The outermost is the less energy that can easily make free by the application of external field, yeah, electric field that we do, that we apply the electric potential or electric field that can leverage the electron for conduction, yeah. That is the ultimate design. But now the issue is actually for the bulk materials, how the moment of inertia actually impact on the acceleration. So think that if we think this is a strip of certain mass, so definitely there this is the normalized force, this is the total force, but effectively the slice that can make it variation this, and this part actually is this. So think that if we make this W actually is the resultant one, should be W cos theta, because here is the angle derivative of theta, and here is W sin theta. So think that then there is a friction F. So how it will balance? Think that the ball or anything is rolling this way. So definitely the force of Newton classical mechanics, the second law, if you think that F is equal to m, say mass is m, yeah, we know W equal to mg. So ma should be balanced with the what? This is the weight versus slide. That is the W sin theta, and that is the frictional force, that is relationship between them. So if so, then we can write that the ma is equal to W sin theta minus. So think that the frictional force here actually we can relate it with the force, and that can eventually make it, you know, that I equal to nr square. So if so, then the m is equal to I by r square. So if we write that f is equal to ma, and that m is nothing but the frictional effect with the moment of inertia, that is I by r square a. So then we can write that this is I r square a. So if we write in that way that ma plus I by r square a should be equal to W sin theta. So think that if we write the A in terms of this relationship, we can find that m plus I by r square equal to W sine theta. So A equal to actually W sine theta by M plus I by R square. So now you can interpret I with a different value, because here it is actually M equal to W equal to mg sine theta divided by M, think that M R square plus I, and here should be R square, yeah? Like this. So now I, actually the moment of inertia is diverse, materials is diverse, yeah? Because we know that for a hollow sphere it should be, for the solid sphere it should be, say in this case, it should be half M R square. But for the hollow it should be M R square. This is hollow. This is solid. You can write the different things with a different aspect. So think that if it is solid, then here that value if it is solid, then here that value that A should be related to mg sine theta divided by m r square plus, say here for the solid it should be half m r square. So it should be actually r square m g sine theta divided by, here should be what? 3, yeah? And here should be m r square, and here should be 2. Is that it? So ultimately it should be 2g by 3 sine theta. 2g by 3 sine theta A. So this is the relationship between translational acceleration and acceleration due to gravity. Yeah? For the solid it should follow like this. So how about the hollow? If it is the hollow, say it is solid, it is A for solid, then A for hollow should be mr square. So it should be r square m g sine theta, then 2 mr square, yeah, because mr square here and here is mr square. So it should be actually g by 2 sine theta. So think that this is the differences between the hollow and solid sphere, the moment of inertia impact on the linear acceleration. Because for the solid, due to the lower moment of inertia, it impacts on the lowest. Is it lowest or highest? It should be compared to this. Lower moment of inertia impact higher acceleration, and the higher one, hollow one, get the lower. So what does it mean? If the acceleration is lower, so which one will drop faster? This one or this one? Which one will drop faster?
No.
Solid.
Definitely solid one, yeah?
Yeah.
That means the moment of inertia lower can impact on get a faster fall. So that means actually it has time dilation. That though we are talking about the physical aspect of moment of inertia, but it has time dilation with the system. So it is not only that the hollow or solid sphere, different dimension of the material that must impact on the translational acceleration due to variation of the moment of inertia, because g is constant, yeah? The acceleration due to gravity is constant, while the translational acceleration is changing with the effect of the the moment of inertia, yeah? Or the dimension itself. So think that this concept of the bulk body, that is talking about the large elements, and this concept with the tiny element as atom, actually how can interrelate? Because as an electrical engineer, you should think about that, how the electrical system actually governed with the mechanical relation to deliver the electric field or energy to. Because for advanced research it is important to learn that the hot materials is actually supposed to get more conductivity with less thermal effect or mechanical effect. That is important for advanced knowledge. But not now. It is not undergraduate level, the higher level of studies. So that's all from this interpretation. Yeah, thank you. So,